Hello students, welcome once again to your chemistry class. In our last class, we looked at isomerism, where we made mention of the various types of isomerism. And we said that we have the structural isomerism as well as stereo isomerism. Today we are giving attention to stereo isomerism. Now, what do you mean by stereo isomerism? First of all, when we have the word stereo, stereo means space. So the type of isomerism that deals with space. Now, when organic compounds have the same structural formulae but differ in spatial configuration, such isomerism is called stereo isomerism. They have the same structural formulae but differ in spatial configuration. Such isomerism is called stereo isomerism. And two types of stereo isomerism are geometrical isomerism and optical isomerism. Today we are giving attention to geometrical isomerism. Now, geometrical isomerism is otherwise called cis and trans isomerism. Cis and trans isomerism. It is a type of isomerism that does not allow rotation around the double bond due to the presence of pi bond. Rotation is restricted. The presence of pi bond or double bond restrict rotation in the molecule. So we have cis isomer and trans isomer. Now, cis isomers are formed when two larger groups are on the same side of the double bond. And then the trans are formed when two larger groups are on opposite side of the double bond. For example, you have something like butene. Look at this. You have two butene. Look at the structure. You have CH3, CH double bond, CH and CH3. This is just normal butene. But when we begin to arrange it to be in isomerism form, we will have stuff like C double bond, C, then H, and then H, then C, H3, and CH3. So you see that CH3 and CH3 are larger components compared to hydrogen atoms. And therefore, since the two larger groups are on the same side, we call this cis isomer. And because it is formed from two butene, we call this cis 2 butene. Go. Now, if we alternate it now, make the larger groups to be on opposite side of double bond. We have stuff like this: C double bond, C, then C, H3, and CH3, then H here and H here. If you look at this compound, you see that the two larger groups are on opposite side of carbon bearing double bond. This is carbon bearing double bond. This double bond is otherwise called pi bond. And since the methyl group are on opposite side, they are not on the same side. They are on opposite side. One is up, one is down. We call this trans isomer. And since this coin, or it was obtained from butene, from 2 butene, we call this trans 2 butene. So this is a typical example of geometrical isomerism. These two other compounds are geometrical isomers. Another example of it is something like C double bond C, then you have CH2, CH3. Then here you have H. Coming here you have CH2, CH3. Here you have what? H. You can see that these two carbon atoms are bearing double bond. And you have CH3, CH2, CH3 attached to it, CH2, CH3 attached to it. These are higher groups. These are higher groups as compared to hydrogen atoms. And since they are on the same side, the two ethyl group, the two ethyl group are up. We say this is cis isomer. This is cis isomer. So we call this 1, 2, 3. Okay, 1, 2, 3, 4, 5, 6. So you call this cis 3-hexene. Cis 3-hexene. That's what we call it. It is cis because the larger group are on the same side. Now, if you alternate it, bring one down and the other one the other way around, you're going to have stuff like this: carbon, double bond, carbon, then C, H2, C, H3. Then here you have your H. Coming here you have C, H3, C, H2. Then here you have what? Your H. Now you have alternated. Now the higher components are no more on the same side, but they are on opposite side of carbon bearing double bond. So we say that this type of isomer is trans. So we call this trans 3-hexene. Trans 3-hexene. So that is how you name the isomers. Okay. So just have it summarily that geometrical isomerism is a type of isomerism in which there is a restriction around in the molecule, a restriction in the molecule due to the presence of pi bond or double bond, and they are otherwise called cis and trans isomers. Cis is when the group on the same side, trans when they are on opposite side. Thank you very much.